So here's the second example at the solving problems with kinematics. So a car accelerates from its parking space and moves in a straight line. Its velocity v meters per second at time t satisfies, and then you've got the two equations there for different time periods. So velocity from 0 to 2 seconds is 14t minus 5t squared, and for anything greater than 2 seconds it's 13 minus 20 over t squared. So part A, find the displacement of the car from the parking space when t equals 2. So look at the time, t equals 2, so we're going to use the top equation for velocity. So again, think back to last week, how do I get from velocity to displacement? So I know that I need to integrate velocity. So I'm going to integrate 14t minus 5t squared with respect to t. Remember, you need to be pausing this at all points to write stuff down. Maybe even having a go at it by yourself if you fancy, and then looking back at what I've done. So if I integrate that, we're going to get 7t squared minus 5t cubed over 3. And our limits, I should have said at the start actually, it's going to be 2 and 0. We want to see how far has it travelled, the displacement in those first 2 seconds. So we'll substitute 2 in. And then subtract when you substitute 0 in, but obviously that's going to be 0 in this case. And then once you substitute that in, you will get 14.7 metres. Okay, right, second part then, when t equals 5. So again, look at your time, so you'd think, right, t is greater than 2 seconds, so I'm going to use the second one. But the mistake that people make is that they're going to think that's for the whole of the 5 seconds, whereas you need to consider the first 2 seconds. It's got a different equation for velocity, so you kind of need to use both equations with this. So for the first 2 seconds, you know that it travels 14.7 metres. So we need to remember that for the first 2 seconds, that's the displacement. So now we just need to look at the displacement between 2 and 5 seconds, and in that case we can use the second equation. Now, to make it easier for me, what I did, you don't have to do this. I rewrote it like that. I did it as t to the power of minus 2. It's whatever you prefer. In the textbook it doesn't do that, but I prefer to leave it like that to do my workings out, and then I'll turn it back into like the fraction afterwards, but it's entirely up to you. So if I integrate that, we're going to get 13t. I just find it easier with the powers, because now I know it's easy to add 1 to minus 2. So it's going to be positive 20t to the power of minus 1, because you're timesing the negative by negative 1. And then your limits, again, 5 and 2. So if we substitute 5 in, and we substitute 2 in and subtract that, and you end up with the first part being 69, the second part being 36. So altogether, the displacement between 2 and 5 seconds is 33 metres. Now we've got to go back between 0 and 2 seconds. We've got 14.7 metres for the displacement. Between 2 and 5, we've got 33 metres. So altogether, it's a total displacement of 47.7 metres. Right, part B. At what time is the car 35 metres from the parking space? So again, if it's 35 metres away, we're talking about displacement. Now, going back to the first part, We know at 5 seconds the displacement's 47.7, and we know at 2 seconds the displacement's 14.7. So 35 metres is somewhere in between that. So we know that it's going to be between 2 and 5 seconds. So if it's between 2 and 5 seconds, this is the equation that we're going to be working with. So I'm just going to rewrite that one, because obviously I can't see that on here. Okay, so that's for greater than 2 seconds, and we know it's going to be greater than 2. So we know that the total displacement then, it's going to be the 14.7 that we've got for the first 2 seconds, but we don't know where between the 2 and 5 seconds the 35 metres is going to come from. But we do know that we're going to need to integrate this to work it out. But we don't know what the limits are going to be, but we know the lower limit's going to be 2. The upper limit we can just call uppercase T. And that's what we're trying to figure out. We're trying to figure out what is this time going to be. And then we know that all that is going to be equal to 35 metres. So the first 14.7 metres of displacement is in the 2 seconds. And then the rest of the displacement is going to be within this section when we integrate that. I should have put dt on there. So I'm just going to make that a little bit simpler so it looks tidier. So I'm going to move the 14.7, get rid of the 14.7 there. So we'd have 20.3. So if we integrate this, which we already have done on the previous question, so I'm just rewriting that. So it's 13t plus 20t to the power of minus 1. Don't know what this upper time limit is, but we know that's 2. And that's going to be equal to 20.3 metres. So I'm going to just substitute in the upper limit for the time, what we're trying to work out. Then substitute in 2, because that's what I'd need to take away. And that's equal to 20.3. When you work all of that out and then add this amount here onto the 20.3, you're left with 13t plus 20t to the power of minus 1 is equal to 56.3. Now that looks like a tricky equation to solve, so what I'm going to do now is rewrite that t to the power of minus 1 as a fraction, and it will become clearer then. I mean, you might already have it like that anyway, what to do. So to eliminate that divide by t, I'm going to multiply everything through by t. So it's 13t squared plus 20 equals 56.3t. So you can see now that we've got a quadratic. We just need to rearrange it, make it equal to 0. So I've got 13t squared minus 56.3t plus 20 is equal to 0. Stick that in your calculators to use the quadratic formula. Your two values for t, 0.390 to 3 significant figures and 3.94. Now obviously we know that it's got to be a time that is between 2 and 5 seconds. So this eliminates this one and leaves us with the final answer. It's at time 3.94 seconds. All of these examples are taken from the book as well, so it might be worth, after you've listened to me and my way of going through it, going back to the book and having a look too.